afternoon. Hello, hello. Ready to go? How are we doing? We're officially in May. Whew. So, how about you spend some time, like a minute or two, to do these two and see if you can find the sum of these. Do number one first. We'll do number two together. Well, do number one, then try number two. Okay, I want you to apply the formula that you had because, I mean, anyone can add 4 times, right? But I want you to use this to apply to that, okay? The hint is you use the trapezoidal formula we talked about before. And see if you can figure that out, okay? Spend some time to do this one if you just got here. Let me know when you're finished, okay? Or if you think you got an answer. Alright, so let's take a look. So what is the pattern here, if you can tell me? So you're looking at this is, instead of triangular, this is actually looking like a trapezoid. You can draw this if you want to. Okay, so it'll be like 2, the next one will be 5, right? And the next one will be 8. The next one will be 11. So you can see that it's going smoothly down. you can draw its reflection. 4, 5, 6, 7, 8, 9. Yeah, 11, right? Then what you realize is that they can make a rectangle, just like the rectangular, triangular one can make a rectangle. So how do I do this? It will be 2 plus 9, right? So 2, will be 4 times 11. So 4 times 11, and then divided by 2, right? Because that would be half of that, which will give you, wait, am I counting this right? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. 4. Oh, never mind. I'm missing a whole row here because that wouldn't be symmetric, right? So it'll be 4 times 13 instead. Sorry. So it'll be 26. Okay. It'll be 26. You want to cut it like this. Okay. So that's a graph, but I mean diagram. But if you really want to do it, it would be a trapezoid. So you do 2 plus 11. All right. So remember trapezoidal formula, it's 1/2 base 1 plus base 2 times height, right? So that means it's 1/2 base 1 will be 2 plus base 2 is the bottom one, which is 11, because the last one 1, 2, 3, 4, 5, 6, 7, like this, 2 plus 11, right? First plus last, times height is number of terms, so times 4, which is same thing, 26. Okay, so either way you should have it work. Now, if we want to use the same equation, we need to find the 50th term first. Remember what we need to find the 50th term? What kind of progression is this called? 2, 5, 8, all the way to 50. What is this? What is this called? What kind of pattern? What do we call this progression? Or what's the pattern here? Because we need to find the last term before we can do the sum, right? So how would I do that, and what is this pattern? Type it up, type it up. What do we call this? Arithmetic. Thank you, Miles. Thank you, Seung-Hoon Lee. Thank you very much. All right, so by 3, right? Thank you, Seyoon. So that is, right, an equals a1 plus n minus 1d, right? Remember this formula we did? So in this case, like Seyoon said, it would be 2 plus n minus 1. But in this case, the n would be the number of terms, in this case 50. So 50 here. So it'll be 2 plus 49 times 3, which is what? Which is what? 146? No. 149? What is it? 147? Oh, 147 plus 2, right? So 149. Is that right? 49. So, is that right? Right, 27, 147 times, yeah, okay. So that's the 50th term. So so this is 149 then. So you're gonna do 1/2, first plus last, right? Times height, which is how many terms? Which is 50. So if you multiply this out, you will get 3775. Okay. All right. So what if we have this instead? So instead of knowing a term, can I find an equation that I can find any term? Well, that we need some sort of manipulation, right? So it goes like this. We need to first find the last term was this, right? So we're gonna find for any term, we're gonna use the one with n only. Okay, so it'll be 1/2. 2 was the first term, still the first term, plus the term you got for n was 2 plus n minus 1 times 3. Okay, I'm just trying to mention that this was your formula for Tn, right? This is Tn. So that, right, 1/2 that, and then times number of terms, which is n. Okay. Let me label these things. Okay. So that would be that, and then you can simplify, obviously. If you simplify, it will be 1/2 4 plus n minus 1 times 3 times n. Or if you want to further simplify, it would be, what's this, 3n minus 3, so it would be 3n plus 1. 2n, yeah, 3n plus 1 times n. Okay? It's just simplifying. I mean, you don't always have to. Depends on if it calls for it. If it doesn't call for it, you don't have to simplify. How are we doing so far? Are we still within reasonable cognitive demand? Alright, so then, you know, in general, your Sn would just be first plus last, right? So A1 plus An, right? First plus last times number of terms divided by 2. Okay? That is your formula for arithmetic sequence. Sum of arithmetic sequence, which we call this arithmetic series. Okay? Series is sum. Okay? Series is sum. Like when you're watching a TV series, right? You don't talk about individual things. You're talking about the show as a whole, right? When you add all these wonderful episodes together, they make a series, right? So when you're referring to a list of numbers, that's sequence. If you're adding the sequence up, they become a series. Okay? Kind of make sense? Alright, so can you find the sum over here? When you're done using this formula, okay, when you're done, let me know. I'll give you 2 minutes. If you're not done in 2 minutes, then we'll go over it anyway, okay? Can I call attendance real quick, since we're all here? So if you're here, press here. Am I lagging? What is this? Why does it seem like I'm lagging? Interesting. Well, it looks like I'm okay now. It's lagging a little bit. Also, your grades are updated for the recent assignments. So if you haven't done it and you're receiving zeros, please make it up ASAP. Yeah. Otherwise, you might have problem getting credit, which would be totally a sad thing because I wish you guys all can pass, which you could. But, you know, if you don't do the work, how can I pass you? Right? So yeah. Please do your homework and submit them in time. I also believe that there's one or two people who haven't joined the Google Classroom for some reason. I can't help you if you can't join the Google Classroom, okay? So if you haven't joined the Google Classroom, please go to my email about Google Classroom. Yeah, I think it's a loop mail. There's a code there. Just type it in. I'm not gonna type it here, okay? Just go see your loop mail, find that Google Classroom code for my class, and come in, okay? All right, so we're done with this. Take a look. So you want to add from 3 to n, right? So number of terms you don't know yet. So, well, it's nth term, right? So it'll be, so it'll be, right, Sn equals, number of terms is n, right? And you have first plus last. Last is Tn, right? We'll just put Tn for now, or An, whatever you put, Tn or An, that doesn't matter, over 2, right? That's what it looks like. But you can use your formula for arithmetic, because this is arithmetic, right? So you can use your arithmetic sequence formula, which is 3, right? First term plus n minus 1 difference right now is what? 2, right? So that's basically done. I'm missing a parentheses right here. Okay, so that's basically done. You can further simplify, of course. So if you further simplify, then this would be, so it'll be 6 plus 6 minus 2, so 4, and 2n minus 4. Okay. Does it look good? Wait, 2n plus 4. Just kidding. Plus 4, plus 4. Okay, 2n plus 4. 2n plus 4. All right. How are we doing? Let's try these two. So let Sn be sum of first n terms, first 4 partial sum, and graph and Sn. Okay. Well, so if you do this one, this will be Sn is first n terms, right? So it'll be n times 2 first term plus last term, which is last term is, well, I'll just put an here. All right, I'll do step by step. Okay, so then an, because this is arithmetic, you can again do 2 plus m minus 1. Difference is still 2. Okay, and of course, because you want to graph it, right? So you kind of want to simplify it. Okay, so it'll be 4 minus 2, so plus 2, 2n plus 2. And because we're graphing it, right, we want to graph it. So we want to simplify a little bit. So it'll be n plus 1. Okay? Part B, they're asking you first 4 partial sum. 4 partial sum means n equals 4. So S4 is equal to 4 times 4 plus 1 equals to 20. That means if you add from 2 to 4, 6, 8, 10, so 2 to 10, you will get 20. Okay? 2 plus 4 plus 6 plus 8 plus 10. That's, wait. 2 plus 4 plus 6 plus 8. All right, four terms. Then you'll get 20. Okay? I'll put it up here, just in case. You're trying to add this. Okay? But that is when n is 4, right? Because there are 4 terms. That make sense? All right. So then the last one is graphing, right? So I'm going to briefly graph it. This is called a parabola, right? Because this is n plus 1. So when you graph this, you can find 2 intercepts. One is at 0, one's at -1. Okay, and then when you graph it, it looks like this. Okay, parabola. Oops, like that. But obviously, you're not really caring about anything that's on the left, and you're discrete. So kind of goes like by points. Okay, so none of this, these are out of its domain. Okay, none of these. So just this part. Okay. All right. Number 5. I guess they didn't miss it. They want to add all the way to n term. Can you do this one real quick? I'll give you a minute or 2 minutes. Okay. take a look. So Sn is n times 4 plus last term an over 2, right? So in this case, the term was 4 plus n minus 1 times 4, right? Very similar. And then over 2. And then what you're going to get is n over 2, and then you get 8 minus 8, so 4, so 4n minus 4. So you're going to get n, 2n minus 2, right? And then your S4 is going to be, 2n plus. And then you're going to get 4 as 4, 2 times 4 plus 2. So that's going to be 1040. Right? Which means you're going to essentially have the same thing, but slightly steeper. Okay? Still negative 1 and 0 as your intercept because you have 0 and 1, right? But this is steeper, so your graph will also look a lot steeper. Okay? None of this. So let's compare these two. If you look at left and right, you'll notice that, oh, look, they're exactly double. Well, this is exactly double of that. Why is that? Well, because every term is doubled, right? Wait. Why is n equals 4? Because, you're talking about that right here? Or you're talking about up here? So you plug in n equals 4 to get the sum of the first 4 terms. Which one? Which n? I'm talking about this one? H? Where's H? Oh, I screwed up. It's actually 6. Good call. Because the difference is 6. Okay? 6. So this is 6n plus, what is this? 2, right? 6n plus 2. Then 6n plus 2 over 2, which is 3n plus 1. Good call. And then you'll get 4 times 3 times 4 plus 1, which in actuality is no, 4. What? Oh no. Wrong. But your intercept will then be at 0 and negative 1/3, and your parabola will be a lot smoother like this. But again, you're not using any of these, so it'll just be here. Okay. I think it's good now. Yep, back to HD. All right, so that's fine. Let's look at. Let's take a survey. 1 to 10. Give me something. Give me a number if you get this. 1 to 10. 7.6. 8. 8.35. 7. Alright, good enough for me for now. So take a look at this. I think you're pretty good at multiplying, right? So spend some time multiplying this out real quick. See what you get. Multiply this whole thing out, okay? No shortcuts, which means that you actually multiply this out, okay? How do you multiply it out? Do term by term, okay? I'll do to 1 first, okay? So I copy every term, okay? Right? And then every term multiplied by negative x, so that means it's minus x squared, minus x cubed, minus x fourth, minus x fifth, minus x sixth, right? What do you notice? Can I simplify this? What is this equal to? What is this multiplying into? Can it be simplified? That's for the next one. So what does it simplify into? What does it simplify into? I want to start singing. That's bad. Or that's not bad, but not the appropriate time. One minus x to the fifth, right? Because you cancel every single one of them in between, pretty much. Because everything here will be canceled. Okay. Then what do you think this will simplify into? Well, you do the hard work. But it should simplify into something, right? What should that simplify into? Hey, how are we doing? Isn't it 1 minus x is 6? Well, it's too late. I already answered. So, it's okay. It's okay. I was, but it's okay. Thanks. Anyway, I'll say on the chat next time. So, then, knowing this, can I simplify this? Isn't that equal? So take a look, okay? See, this times this equal that, right? Then isn't this equal to 1 minus x is 6 over 1 minus x? Right? Isn't that right? You agree? Oh, so knowing that, what if I change, instead of 1 plus x squared plus x cubed plus x to the 4 plus x to the 5th, isn't that the same thing as, so instead of doing this, I'm doing 2 instead. Isn't that, I just use the same formula, right? Because it's the same exact thing except x is 2. It's like that. Isn't that equal to 1 minus 2 to the 6th power, 2 in my head, 64 over negative 1? So it's positive 63. Okay. So, in general, if you want to find this, 1 plus x squared plus x cubed plus x to the n, isn't that the same thing as, so it was 1 minus x6, right? So in this case it would be 1 minus x. So 5 is 6, n is what? N plus 1, right? Right? Over one minus 2. Right? Isn't that the same thing as not 2, just x. Sorry, just x, no equals, because this is x. Okay? So that's the general formula for that. However, if we change it to this, what is this? Isn't this the geometric sequence sum? So it's geometric series, right? So T1, T1R, T1R squared, T1R cubed. So this looks fun, but I have T1 in common, right? There's just an urge in my body that I really, really want to factor this T1 out. If I do that, then the rest should look like this. Okay? Now, if that is the case, add all the way to r to the n minus 1, right? If that is the case, then this will then be T1. I already know this formula. This was 1 minus r to the n plus 1, but n right now is n minus 1, so it's just n. Okay, say that again. This is until n minus 1, so it's just n. All over 1 minus r. So this is the geometric series is sum. So if I want to add geometric sequence together into a series, that would be my formula. Okay? How are we doing? Alright, so that's why we have this formula. The good thing about this one is you don't need the last term. Notice that I only need the ratio and the first term. Okay? So you need first term and ratio. Okay? Well, it's until the nth term, because remember n term is, right? Gn is what? G1 r to the n minus 1, right? So we are ending up in the nth term. Okay, because you start from 1. 1 is the first term, right? So when you do T1, right? T1 is term 1. The last term, Gn, is g to the n minus 1. Right? R to the n minus 1 power. So it is the n minus 1 term. Is the nth term. Okay, so this is Sn. Okay, so the box one will apply to any n term. Okay. All right, let's apply this to some problems on the next page. So I'll write it because this one is slightly harder to remember. So I'm gonna write here T1. You can do T1 or G1. It's up to you. This is just notation on, this is the first term, okay? 1 minus r to the n over 1 minus r, okay? All right, so in this case, first of all, you have to identify as geometric, and I know it's geometric because they multiply by 10, right? Times 10 times 10. So r is 10, T1 is 8, right? You have these two. So then you can apply. So Sn is right? 8, 1 minus 10 to the n power over 1 minus 10. Like that. And because you don't know what n is, which means you can't find the sum, because however many terms you end up with, that's your formula, right? How are we doing here? I'm just applying the formula for geometric series. Okay. Next one. So first term is obvious 2/3, right? Is this geometric? Is this geometric? Type in the chat if you think it's geometric. What is the ratio? Because geometric has to have a ratio, right? What would be the ratio if it's geometric? If it's a yes, that means you found a ratio, right? So yeah. If it is, then you have to give me a ratio. Ratio is 1/3, right? You're multiplying by 1/3, right? Divide by 3, that means multiply by 1/3, okay? If that's the case, then I said, right? I'm gonna follow T1, term 1, 2/3 times 1 minus 1/3 to the n power all over 1 minus 1/3. Now, good thing is, these two are the same thing, right? See, subtract. 2/3 and 2/3, it cancels. So I'm just gonna get 1 minus 1/3 to the n power. Okay, whatever that becomes. Didn't tell me the number n, so I will leave it as n. Make sense? All right. So next thing, find the sum of all positive three-digit numbers whose last digit is 3. Isn't that a little tricky or not? Well, let's see what it looks like. So all positive three-digit number. What's the first three-digit number whose last digit is 3? What's the first one? What is the first three-digit number that last digit is 3? Type in the chat. 103 is correct, right? 103. So that means you have 103, right? That will be your first term. The next one would be what? And that 113, right? And then 123, 133, right? It has to end with 3, and then all the way to the last one is what? Before the last digit, before 1,000, right? Is that 993? Right? So, is this arithmetic or geometric? Type in the chat. Arithmetic or geometric? If it's arithmetic, tell me the difference. If it's geometric, you should tell me the ratio. So how does it change? It's in the plus 10, right? All right, so the last term is 993, right? So your sum, isn't your sum first term plus last term, right? So 103 plus 993 times number of terms, right? Times number of terms divided by 2. The problem is, how do I know this number? Right? How do I know the number of terms? I kind of have to get from, well, not kind of, I have to get from the relation, right? From 103 to 993, how many terms are there, right? So if you do 103 plus n minus 1 difference is 10, right? Is equal to 993, right? Because this is supposed to be the last term, Tn, right? Or An, whatever you call it. Okay? So then you solve for n. Okay? Subtract it over. N minus 1 times 10 is equal to, I think this is what, 890? Right. Subtract 103 over. Divide by 10, so n minus 1 is 89, so n is 90. Okay? So once you found n is 90, you can plug 90 back into the equation, which is here. Put 90 here. So when you multiply this out, 49,320. Okay. So, recap, you first figure out what they're asking for. In this case, is arithmetic series of difference 10. And you want to figure out the sum, so you use the trapezoidal formula, or first plus last times number of terms divided by 2. You're missing number of terms. To figure out number of terms, you have to figure out how many terms are actually here. So you use the last term formula, Tn equals first term plus n minus 1d, and then you figure out n is actually 90. Okay. Last one. Before you can ask a question, or you can try the last one. Go ahead. All positive odd numbers less than 400 divisible by 5. Okay, so you kind of have to list a few out before you talk about what kind of series it is. Okay. So, list them out, right? So, first one divisible by 5 is obviously 5. Okay? Next one is 10, but 10 is not odd, right? You need to be odd. So, next one's 15. And the next one's 20. 20 is even, so next one's 25. Then 30 is even, and 35, right? You see where this is going? What is the last one? Less than 400, right? So 395. Okay, so that would be your series. So you're trying to find this, and then you're adding it up, right? So arithmetic or geometric? This has to be plus 10 each time, right? So arithmetic and 10, right? So you find it's the same problem then. You have to find the relationship between them. So 395 needs to be equal to 5 plus n minus 1 difference is 10, right? So then you solve for n. Then that way you can find number of terms. So how do I know to do this? Because I already did once from the previous problem, and that's from experience. I would need this information. Otherwise, I would just be here at Sn equals, do the sum, and you realize, oh, I need an n. Realize it afterwards, right? But since we already know we're going to need it, we'll just solve it right away, okay? So 395 equals 5. I mean, you can multiply it out if you want, okay? I would multiply it out just so people who like to multiply them out can multiply it out. So it'll be minus 5, move it over. So 400 equals 10n. So n is 40. Is that right? 40? So if n is 40, then you have 40 first plus last, right? Divided by 2. End up being 8,000. Okay. How are we doing? Questions? Give me 1 to 10. So I understand if you need more time. Ooh, I got a 10. Give me a 1 to 10 so I can give you an idea. 9.35. Not bad, not bad. Okay, looks like we're pretty good. So your homework this week is 2 half worksheets. They're in separate files on the assignment on Google Classroom. So if you go and find your assignments, due this Sunday again, May 10th. Okay, make sure you do them. Like I said, you are responsible for your own assignments, right? Shouldn't take too long. So they're 2 files, but they're of half a page each. Okay. Any questions before I let you go? Any logistic questions or conceptual questions? Anything? No? Anything? Well then, I will see you next week. If you have a question on any of the homework, I can go over them in the office hour. Just hit me on Remind or email. If you like the video, smash the like button, hit the subscribe, tick that little bell. I'll see you next week. No problem. Goodbye. Goodbye. Bye-bye.
Well, I gave you all my love and I gave you all my trust and I gave you everything that you need. But you only told me lies and you made me realize that, babe, you ain't no good for me. I can't be with you, you can't be true. And I know just what I got to do. Gotta hit the ground running, running just as fast as I can. Gonna hit the ground running, running just as fast as I can.
Goodbye.
Well, you're begging me to stay, but I'm